So just to give everybody a heads up, this is Natural Language Meets Natural Systems, designing usable AI interfaces for climate data. So a lot of topics that we've covered today, I'm sure everybody's run up against artificial intelligence in some form in their conversations. This is going to be a little bit of a different talk, focusing around enabling you to approach any necessary problem you have designing interfaces using user experience or human-centered design concepts. So to start off, I want to give everybody a warning. We are being recorded. You guys are all familiar with this to some degree. So if at any point you have any concerns or have a question that you may not feel comfortable communicating on a recorded platform, please feel free to reach out, either the Slack, the Zoom chat, reach out to me via LinkedIn, Carrier Pigeon, whatever you're comfortable with. Okay, so as well, we are being watched, as I mentioned. If you have a cell phone, please go ahead and feel free to grab it. We have some interactive elements. Most of us have interacted with the Slido at this point, and big surprise, there's more. So just be ready with your cell phone with an internet connection to interact. So the purpose of our talk today is I want to arm everyone here with the tools necessary to champion a human-centered approach towards artificial intelligence. We've all seen it in a lot of different formats, and we've all seen it take a lot of different shapes, applications, whether that be LLMs, whether that be some other system, some processes. So I want to enable all of you to have the tool set to question the application and question the design and really ensure that whatever you're building is providing a meaningful service to the targeted community. So to start off, what do we mean by a human-centered approach? To start, we need to understand what human-centered design, or HCD. You'll also hear this referenced as user experience. They're interchangeable. But what do we mean by human-centered design? Human-centered design is a problem-solving approach focused on designing products, systems, or solutions around the needs, behaviors, experiences, and perspectives of the people who will use or be affected by the end product. Okay? So what we need to ask ourselves first is, what is our solution? So I don't know how many of you were a part of the Design Data Services for People provided by Kate Wing and Kit Luer. An amazing talk. If you have time and are interested in these topics, I greatly encourage you to go back and watch the recording. She does an amazing job of teeing up a lot of the concepts that we're going to talk about. I would say that hers is more foundational. Ours is maybe one step above that in how we apply a lot of the tools that she provided. So to kind of carry that thread through the conversation, I adjusted my presentation. We're not going to ask ourselves, what is our solution? But we're going to leap off of what she set up. How we might solve a problem, how we might improve a system, how we might develop a new tool. The one thing that I want to put on everybody's mind real quick is we all approach problems with this kind of mindset. How are we going to solve it? How are we going to do it? What I want to propose to you is don't approach it with that, but how we think we might do it. And to start off, I want to give a little bit of a story to kind of frame up this concept. So in World War II, there was a significant amount of naval activity in an offensive manner, where there were a significant amount of bombers used to execute offensive maneuvers. These bombers were met with a significant amount of ground-to-air defense, and they were either losing a significant amount of planes or coming back significantly damaged. So they're returning from these missions, and the Navy is deciding, how do we make this more survivable? We're rebuilding planes at a constant rate. So why don't we look at the data of the bullet holes where the planes are coming back? Where are those bullet holes at? So they start to collect data, and they create this distilled image where they start to collect on the fuselage, the end of the wings, and the tail here. So this is a distillation of a lot of information of where they saw most damage on planes that returned. Okay? So the Navy decided, we have all this data here, let's start armoring this plane, let's make it more survivable, let's start saving our airmen, as well as not expending so much money constantly rebuilding planes. So I would like to pause really quick. If everybody looks at this data real quick, and it's real simple, what I want you to do is go ahead and pull out your phone, and I want you to take a guess, based on purely this simple information that we have in front of us, where would you recommend adding armor to make sure that this aircraft is more survivable to execute offensive missions. And I apologize, everybody get a chance? The next slide will have the QR code as well. Perfect. And hopefully this prompt comes up, and we'll just give it a moment. And I want you to just take a best guess. There's no right, there's no wrong. I just want you guys to interact with this information and kind of make a best guess effectively. Are they? Okay, well, as with all information and all technology, there's always a bug. Oh, here we go. I spoke too soon. We got one. Cockpit. One of the 9. Okay. Sweet. Yeah. Thank you so much. Okay, awesome. So we have a decent amount of cockpits, engines, and fuselage. So based on that information, we have a lot of really intelligent individuals in the room. So I'll continue with our story really quick. So with aircrafts, it's a battle between physics. You want to add armor, you're adding weight. So you can't add just constant armor, constant weight to a plane and have it still fly. So what they did was they reached out to mathematician and statistician Abraham Wald. Abraham Wald was a part of the statistical research group that was a part of Columbia University. They reached out to him to start to figure out and execute the math on how much armor they can add to these areas and still maintain maneuverability and aircraft efficiency, while saving their airmen and the investment in the planes. So the SRG, this was not an abnormal request from the military or the Navy. They were constantly referred to execute this kind of computational science to figure out these questions and answer and help inform their engineering choices. So Abraham Wald started by looking at this data, and he started to execute his statistical analysis and figuring out where we can and cannot add armor. And he came to the conclusion that we're not actually looking at the entire data set. We're looking at only what survived. We're looking at only what came back. So what he came to the determination of was that these areas that we are seeing on the slide here are actually areas where the planes can sustain damage and still be survivable. So rather than adding armor to the highlighted areas, he actually proposed that we add it to the areas in which we have no bullet holes showing up on returning planes, because those are where these planes are more susceptible to damage. So he proposed this idea to the Navy. They ended up implementing it, and he actually, his solution and his approach towards this problem actually was in use well into the Korean and Vietnam War. And this is actually where we get the term survivorship bias. He was the first individual to implement this concept of we're not looking at the entire data set, we're not looking at the entire problem, we're only looking at what we can see in conducting our calculations. So why does any of this matter? We're at ESIP. This is a very weird story to tell. The reason why I want to share this is because when we're approaching these problems, we need to make sure that we're not looking at what we only have visibility towards. We need to understand the entire picture, the root of the problem. There's a lot of elements that go into these issues or these challenges and what we're trying to solve, so we need to make sure that we get a greater context and understand the large picture so that we're not looking at just a slice of it. So how do we necessarily do this with some of these abstract concepts as far as digital platforms, tools, systems, anything? This is where the UX process comes into play. So for those of you that were present to attend the Kate Winger's talk, her UX process was a little bit trimmed down, but for today's purposes, we're going to kind of flesh this out so that we understand how to apply it in a lot of our situations. So to start off, we always want to start with a line over here on the left. We want to really understand our goal. We want to define it. We want to try and wrap our head around it. And then from there, we want to research. We want to create empathy. We want to understand the setting of the problem space. And we want to identify our direction from there. And then from there, we have our design, envision product, validate direction, and then build, create user interfaces, ensure quality, and then mature, stand up a center of excellence or enable your organization to keep this product or keep the solution moving forward. So we understand these kind of high-level buckets in which we want to approach this with. How do these actually come into play? What do they look like within a digital tool building scenario or a system building scenario? None of these are necessarily limited to a digital medium of creation. This is something that you see applied towards any kitchen tool. User experiences push forward very heavily in that space. But the way that we see these materialize within the digital mediums is through stakeholder interviews or these activities and deliverables. I will call out, you will see a couple of duplicate items across these buckets, and there's a reason for that. It depends on your situation. So the UX process is super helpful whether you're starting from nothing or you're reacting to what you've already built. You're trying to improve it. You're trying to iterate on what you've already established. So for instance, we have our align phase. So a lot of people kind of approach this from the perspective of, I already know what I want to solve, which is great. But again, we're looking at a small context of the problem. And that's perfectly fine. That's a great jumping off point. And the way we do that in larger organizations is we want to conduct stakeholder interviews. We want to talk with everybody at the top, and we want to define what is success, what is failure. We want to wrap our head around all the ifs, ands, or buts. And then from there, if we already have a product that we're building, we can do product overviews or demos. And this can actually be if we want to look at competitor elements. If there's a tool that already exists, we can look at it and start to go, they did this well, they did this bad. And we start to build out kind of our space, our sandbox that we're going to work with. We have documentation review, pretty self-explanatory. Look at any documents that are already there. Heuristics review. And then we have analytics, service blueprint, style guide, design, and system review. So once we've kind of figured out what our problem space is, what we've defined, what we understand currently, we want to validate our understanding through research. This is where we start to go into user interviews, contextual interviews. One of the best examples of a contextual interview is if you're working with a fast food service, and let's say you want to understand or improve the turnaround time with some form of burger that they make. What you would do is, from all of our perspective, we can understand, okay, cook the burger, put the cheese on, put the lettuce, put the tomatoes, put the bun, put the sauce and everything, and you're done. We probably think that that would take 5 minutes, but we don't understand all of the elements that go into that within a standard setting. For instance, Wendy's. We don't understand their existing system. We don't understand every little granular element, granular, English is hard at 4 o'clock and I apologize, granular element that might influence the speed, might be a hindrance, might be a problem within the process. So these contextual interviews is getting at that ground level and actually watching it being done and wrapping your head around literally everything that goes into play. And then once we have an understanding and we've validated, hey, this is actually the problem that we want to solve, let's go solve it. So from there, we validated what are the actual issues? What do we need to solve for versus what do we think we needed to solve for? Once we have that defined, we go into design thinking, information architecture, card sorting, tree testing, wireframes, high fidelity. This is where we start to sketch out our idea. This is where we start to put it into play, and we get into this position where we're thinking through it in a state where we can pivot quickly, we can change. After that, we build it. This is where the fun happens. This is where fingers hit keyboards and we start coding. We actually start putting this into an application. And then once we have this built, we don't want to just throw it out into the world and say, sink or swim. We want to watch, and we want to see maybe where we were right, maybe where we were wrong. So we can start figuring out our metrics. We can start figuring out user interviews where maybe we made some assumptions, or maybe our initial user interviews were of such a specific slice that it doesn't apply to our greater audience. So one thing that I want to make sure everybody is aware of is that this is not a rigid system by any means. Take any of these activities out of any of these columns, and it will help you answer a question depending on your part of the process that you are currently in. So this entire system laid out isn't assuming you have nothing. You just have a question, I want to improve something, I want to solve this. And you can start from the align phase and move all the way through. But let's say if you're approaching a problem that already exists or a technical solution that already exists, you might need to validate first and go through everything. So These are interchangeable processes that just help answer specific questions. So there's a reason why I would propose starting or leading with user experience or human-centered design. And there's a couple of quotes that do a really good job within the digital realm to define the value that it provides. So from Forrester Research, $1 invested in UX brings a return of up to $100. It's kind of a short quote. I'll kind of give a little bit more color to that. Where most of the money is spent within a development cycle is rework. So if you build something going down the wrong path, put it out into the world, let everybody react to it, you're going to and let's say the solution was incorrect or you need to adjust, you're going to spend 100 times more dollars reworking it rather than identifying the correct problem space from the beginning. And the next quote is that 60% of software features are rarely or never used. We've all put something out there we thought was great, but it just never picked up traction. Either people didn't find it useful, technology moved past it. There's 1.5 million reasons why something might not be used, but this is falling in line with misaligning the problem or misidentifying the problem. So that's where the user experience process helps us make sure that we're on the right track. We want to set up our bumper lanes, and we're trying to get a strike, and the UX process helps us check into those processes, check, and make sure that we're going down the correct path. So we've gone through this high-level concept and everything. I want to define, before we get super deep into the weeds of our examples, what the paradigms of user interaction are. So user interaction can happen in a lot of different forms. We're all familiar with these, but for the sake of today's conversation, I want to lay foundational understanding. We have our command line interface. I am sure all of us in some form have used this. Terminal, PowerShell. We have our graphic user interface, Windows, Mac OS. You all have cell phones, you all have computers. We've all interacted with these elements in some fashion. Then our touch-based, smartphones, tablets, voice user interface, Siri and Alexa, and then our conversational user interface. So this is what we're going to focus on a little bit down the road, where we have our ChatGPT, Gemini, Claude, and customer service bots. We also have augmented virtual reality, which is our Meta Quest HoloLens, gesture-based, Microsoft Kinect, Leap Motion. Now, I have organized all of these in these nice buckets. In reality, none of them live in buckets. None of the applications are only terminal PowerShell nowadays. There's a combination, and we need to be aware of these potential combinations when we're approaching how our target users are actually going to interact with them. Are we creating something that has a conversational UI element and a graphical user interface? Well, we need to make sure that whatever we're presenting is clear of those potential interactions. And we make sure that it is a clear system that they need to operate within. So now that we have an understanding of all the shapes and forms that our users can interact with whatever application or tool that we're going on to build, we need to understand, how do we define a good user experience? How do we define a good human-centered design outcome? The first thing that we need to understand is that usability, or usable. Easy to learn, leverages common interaction patterns, and forgiving of mistakes. Our next one is that it's clear, communicates actions, states, and choices clearly. It's efficient. It reduces unnecessary steps. It doesn't overcomplicate the process. And then this one is more of a personal pillar in my mind, but accessible. We want to make sure that we're not creating any biases and we're not inserting any hindrances to those with disabilities, whether that be visual, mechanical, whatever you may have. We want to make sure that our tools that we're building are accessible to all. And then, of course, useful. Helps users accomplish a meaningful goal. So a couple of examples, because I know I'm throwing 5 words in front of you, but for usability, a good example within a digital platform is a checkout form that auto-formats your credit card number and shows helpful error messages. The next, for clear, is the difference between a navigation system where you have order history versus records. We're splitting hairs there, but that's where some of this clarity comes into play, and it's very situational to your use case or your application or your problem that you're solving. And then we have efficient, autofill, keyboard shortcuts, drag and drops. We can do performance time under that as well. And then accessible. One of the biggest accessibility issues out there, which I'm sure most of us working within the government space, is contrast compliant text. So making sure that we're not putting colors too close to one another within the spectrum to where they're not legible effectively. And then useful. One good example is Google Docs real-time collaboration enables teams to work together fluidly, allows them to edit documents together without stepping on each other too much. So we've outlined our pillars of good UX, we've outlined what we're aiming to do, so let's give a real-world example real quick. So a real-world example, which I'm hoping, I assume everybody's interacted with or to some level heard of, is Duolingo. This is a great application where they have invested a significant amount of resources into actually understanding their target audience and their users. So people want to learn languages, is the problem that they defined. But traditional methods are expensive, time-consuming, and intimidating. Duolingo reframed the problem: how can we make learning accessible, fun, and habit-forming for everybody? So they followed one of the main human-centered design principles, is design for real-world user behavior. Not ideal behavior. So you don't want to force people into a pattern of behavior. You want to meet them where they are at effectively. That's how you're going to get the most use of this, most adoption. You're going to meet people and enable them rather than shoehorning them into a process that they're uncomfortable with. On top of them creating, effectively gamifying language learning with experience, streaks, leveling up, and daily reminders. This is a little bit of kind of tangent, but they did a great job creating somewhat of an emotional connection with their application. The Duolingo owl, for instance, is a mascot, and it cheers you on through your process. It is there for all your wins, your failures, and your successes, and they've created and developed this emotional attachment towards their application. For those of you interested in going down a rabbit hole, there's such thing as dark UX, which they have leveraged, and sometimes they use that emotional connection in a concerning manner. For those of you that are familiar with the application changes to their icon, they kind of weirdly twisted the arm on that emotional portion. So, real quick, I want to open the platform. I want to ask, does anybody, now that we've kind of defined what we mean as good user experience, I want you to go ahead, and let's actually go to this one, so hopefully this will work. I want you to just kind of think and take stock real quick and think through any applications of digital interfaces or physical interfaces that you might define meet these standards or equal, are a good example of user experience. I see Chick-fil-A on here, and I'm very curious. I've not interacted if it's
Go to the drive-thru and you're out of there in 30 seconds.
Okay, it's their drive-thru experience.
The drive-thru, even going in, like, they're so efficient, and I think that that is part of the user experience. Like, when you step into their facility, everything's clean, you're in and out, it's please, it's my pleasure, and you know that you're about to get your food hot.
Interesting. Interesting. I see Game Time app, Spotify, AirPods pairing. Does anybody want to potentially elaborate on any of these and maybe explain their experience and just share their thoughts? We've already got Mark sharing Chick-fil-A, which
Very passionate about that.
yeah, about chicken sandwiches. Okay, so we'll keep moving forward. One thing that I want to kind of outline, and this is another pillar that we can kind of be empathetic towards our users at the end of this process, is that all of these elements, AirPods pairing, for instance, those are quick, efficient, you open it up, you put it in your ear, you're done. You have to put no more thought into, I want to listen to music. So all of these are great examples of managing what we call cognitive load. Now, there's a lot of different elements that come into play when we're thinking about user experience, but this is one that I want to focus on for today's conversation. So what do we mean about cognitive load? What is cognitive load? Cognitive load is the amount of mental effort required to use a system or complete a task. When cognitive load is high, users may feel overwhelmed, confused, or make mistakes. Because of high cognitive load, too many steps for a decision, poor information hierarchy, confusing interfaces, unfamiliar terminology or logic, lack of feedback or guidance. So these are elements that we want to try and manage as designers when we're solving a problem that users are going to interact with or humans are going to interact with. So I want to do a real quick activity. And for those of you that do know what this is, we're going to do what's called a Stroop test. There is no right or wrong answer, but what I want you guys to do is I'm going to give you a verbal prompt. I'm going to put something on the screen, and I would like everybody to just shout out the response real fast. Okay? So what is the color of the word? Perfect. What is the word? Okay. What is the color of the word? Okay. What is the color of the third word? Okay. Okay. What is the fifth word? Fair. Okay. So there's no right or wrong answers here, but what I want to display is just even a simple task such as this, changing up the ask and providing somewhat confusing instructions and representation of information. You all kind of felt somewhat of a slight challenge. Not too much, but it took you a second to go, okay, the fifth word, not the color. The word is a color. So it's that process. That is cognitive load. That is or it's a type of cognitive load is probably the best way to explain that. That's something that we want to manage. We want to eliminate that as best as possible. Another more complicated example is taxes. Let's say you have a tax platform that is not TurboTax. You have to read through all of the rules and you have to understand them manually, input your data, and then manually execute the calculations. Throughout this entire process, you have to be bouncing back and forth between what does this rule say? Okay, so that means this calculation needs to be this, and this bouncing back and forth between these systems and these understandings develops a high cognitive load and a high mental task on our users. So in other words, bad UX, bad experience all around. So we've defined what good is, we've defined what bad is. Now, even if we've hit this out of the park, we hit a home run, if you're at the Mariners game and you hit it out, there are still issues that we can run up to where people aren't going to use whatever we build. And those are called barriers to adoption. So why is this necessarily important? So we want to identify the potential pitfalls of tools that we can build and figure out ways to work around that. Okay? So the first one is resistance to change. A lot of people have a lot of tools out there. They have one shovel that they like to dig with. They know how that shovel works. They know how to get the job done efficiently. If I try and give them a different shovel, they're going to be skeptical of how this might work. That's a grossly oversimplified concept, but people build trust with the processes that they've worked with. So asking them to change that asks them to rebuild that trust. So they're resistant to changing what they're not confident of will work. So the next is insufficient training. So we're not providing them with clear directions, we're not outlining a lot of expectations, and we're really not structuring how they should think about interacting with whatever tool that we're looking to build. And then the next, lack of clear value proposition. Why? Why should they look to use whatever we're building? So none of this is monumental by any means, but I just want to reframe how we look at these problems and think about if somebody's not using it, we need to understand, is it resistant to change? Is it a bad user experience? Are we not clear enough? Is it just not valuable enough? Are we trying to reinvent the wheel in a way that isn't really adding enough value? So, got a summary of all those points here. We're not really providing them enough of a guided tour in any form, but the biggest thing is that these, even if we do good UX and we approach it with the best solution possible, we can still run into barriers of people using it. So, we've outlined everything. Let's move on to natural language processes. So, two key elements when we're going through this, or I apologize, I'm getting ahead of myself. For those of us that are not familiar, natural language processes is the type of user interaction where natural language, spoken and or written, is the main interface between the user and a system. So real fast, I'm going to toss up a quick interface here. Now, this is not a dig at this interface in any form. This is another kind of example, but I want everybody to just look at this. I'm not going to give you any more information other than we have an interface here with a natural language input, and I want you to just think through what you think this is capable of real fast. And just keep that in your mind, and we're going to submit it to another Slido here in a moment. Okay, so we'll move to our next Slido. And with only the bare minimum information that I provided to you, I want you all to submit what you think that that interface was capable of. Okay, it looks like we've got 5 more people still typing, but I'm just going to call out that I don't know why I'm here presenting, because you guys are kind of hitting it on the nose with this one. But what I'm trying to display with this is effectively, without additional clear context of what this is capable of, it's kind of a shot in the dark. Oh, sweet. Okay, so selecting a model, providing a prefix query, selecting tone, accepting query. Okay, somebody has interacted with tools like this before. Chat history, ongoing chats, new chats, making you squint, even better. Answering a question, accepting text typed into the UI. Okay, so we're hitting this on the nose of, I don't know. I can make assumptions as far as what I've interacted with previously with LLMs. So why would we approach a new LLM with the assumption it's capable of doing the other stuff? This is what we call a user pattern, okay? So if everybody here, I don't know, I'm gonna date myself a little bit, but if everybody is familiar with the old first iPhone and the beer drinking app or the candle and everything, those were the first applications, right? As those started to progress, we started to develop user patterns. So everybody here is probably familiar with a hamburger menu. If you see 3 lines, if I threw those up on the screen, your first initial thought would be, there's more information if I click that. That is a pattern that we as designers have trained the mass populace to understand. We're currently at the position where we're training everybody how to interact with these LLMs, and that's something we need to be aware of. There's not a lot of patterns there's a couple of patterns, is probably the best way I should put that. There's a couple patterns established, which is the input here. And we have some form of addition and send, and then this area is what everybody assumes is where that output will come. That is the main standard pattern that has been established. LLMs have been around for a while, but they haven't been as widely adopted until the past couple of years. So these patterns are starting to get created. Things are changing rapidly. So we need to be cognizant of that. One thing that I do want to call out is that I apologize, this might be a little small for everybody in the back, but up top here we have the word new prompt and new chat. I'm going to split a hair here. What's the difference? Perfect. Okay, so all I'm trying to outline with that statement is that that's unclear. Okay, have we established a common pattern within the field that prompt means a singular message, or is a prompt multiple messages? Is a chat a collection of messages? All right? That has not necessarily been established. I'm sure all of us in this room would agree a prompt is one message and a new chat is another, but this is a problem you would run up against with the mass populace. You're running into these issues where we're not managing expectations necessarily, or we're not working through clarity. So one other thing is that expectation management. This is somewhat of almost literally a black box. So we need to make sure that whatever LLMs that we're putting out there, we're very clear with its capabilities. We need to refine what it is capable of, what it is not capable of. That can be done through a lot of different ways. We can provide them sample prompts in here saying, hey, I can do X, Y, Z. But we need to clearly communicate to our users what this tool is capable of, or we're going to misrepresent. We're going to have people coming to have this write their emails or set up their grocery list, when this could very well be let's say this is an LLM for figuring out allergies within certain recipes. This could be a very limited and siloed functionality. The other thing that there's a lot of assumptions is we're all having a conversation verbally, textually, through the Slido, and there's an assumption that everybody can do that through this input. We all know how to send a message, but prompting in and of itself is a technical skill. Being able to build context within this setting is not a skill that the mass populace is necessarily armed with as of yet. With the advancement of these tools, that is growing, but currently that takes a certain level of expertise and knowledge in how these operate to build context within the setting, to tell this machine, I want you to act as a scientist, or I want you to act as a podiatrist, whatever you may want to toss in there. The other thing is handling errors and ambiguity. This is kind of falls hand in hand with the clarity. We're not super clear with what this can do, what it is capable of, what kind of errors it would handle. So we want to make sure that, again, we're clear with the boundaries of what we want them to operate in. And then on top of that, transparency builds trust. When we get a response, it pours out this wall of text. I'm sure a lot of people probably skim through that. They try and read it, but our attention spans are extremely short. So we want to get to the meat of it. If we're coders, we want to get to the code. I'm going to only look back at the explanation when it fails and go, why didn't it work? Oh, you told me here. All right? So we need to be very clear with how this is developing it, or how this is developing these responses. Now, this is a very quick and very kind of surface level explanation of the challenges that we run into with LLMs. One thing that I want everybody to really be cognizant of is that the applications, let's say your banking app, that innately has context on the application side. It's only letting you interact with that platform, that information. This is letting you interact with everything. So we're expecting our users to build that context into it. That is a high cognitive load ask and task that we're now putting on users that previously did not have to do that. So we've gone through our natural language processing. We want to make sure that we manage expectations. We want to be aware that prompting is a skill, handling ambiguity and errors, and then transparency builds trust, being clear with how we're coming to some of our conclusions. So let's get into the meat and potatoes of this. What is this in practice? So everybody here is probably familiar with NOAA, National Oceanic and Atmospheric Administration. Myself and my team have been working on a joint ventureship partnership with them where they have leveraged the Broad Agency Announcement. I apologize, all the acronyms get me confused sometimes. We're working with them through the Broad Agency Announcement on developing a solution in which we're exploring how to leverage the NCCF knowledge mesh in certain digital formats. So this is exploratory currently. This is not something that will be in production, but what we're doing is exploring the boundaries, the easy wins, the hurdles, and starting to document what is necessary to get something to production down the road, if they want to pursue this. So the exact portion of this that we're working on is harnessing knowledge meshes with natural language, joint venture initiative, to identify and study, to determine natural language processing capabilities with NESDIS Common Cloud Framework, NCCF, and Open Knowledge Mesh, KMNLP. And because it rhymes, XYZ, we'll go through all of that with the acronyms. Okay, so here is a quick refresher on our UX process. We want to make sure that we align, research, design, build, mature. These are vague buckets right now. How do these come into play when we're working with these digital platforms? So to start, we want to align. To align, we conducted stakeholder interviews. We collected all of the individuals in a position of decision-making authority and started to ask them, what is success? What do you guys actually want to know? We have this huge ocean and idea of what we want to solve for, but let's start refining that. Let's start getting to the meat of this. So we conducted a handful of one-on-ones where we wanted to understand organizational goals, workflows, and constraints, identify perceived barriers and opportunities for artificial intelligence and natural language processing integration, and then align tool design with real-world priorities and decision-making needs. So our goal at the end of this was to enable our target users to leverage the NCCF Open Knowledge Mesh through an LLM interface. The reason why I outline our target users is at this point, we have not defined who this really is aimed towards. So how do we do that? There's a practice called building out personas within user experience. And we define that the people we want this tool to serve, as a small team, we define that we want this to serve marine scientists, climate scientists, and environmental policymakers. So we've given ourselves a more refined target within this process. So from there, how are these people going to use it? We started to develop sample questions. So what are the current pollution levels in the Gulf of Mexico? How can we improve marine protected areas in this region? And then, can I get sea surface temperature data for the Gulf of Mexico for the past 30 years in CSV format? And then for our policymakers, what are the current population estimates for different tuna species in the Gulf of Mexico based on the latest survey data? This is our approach as the team close to the problem of how we think and how we envision somebody would use a tool like this. If they have access to all of NOAA's, not all, but a certain selection of NOAA data that they can peruse and have in a knowledge mesh format, how are they actually going to use this? And this is how we envision they would do so. So, how do we necessarily validate this? This is somewhat of an idea in a silo. We do so through research. So we set up a user research study, and this would be somewhat of a generative research study and a qualitative one, where effectively we're connecting with our target personas, identifying them, talking with them through the concept of what we're trying to solve for and how they might use it. So our study targets. For the interest of transparency, I'm sure all of us are familiar, environmental policymakers. I don't have any of their addresses nor phone numbers, so they're a little hard to get a hold of. So we decided to X them for this initial research study and focus in on our marine scientists and climate scientists. So our approach. We wanted to use user interviews. Our study goals were to identify how they would use our prototype and then how we would answer our initial questions. Okay, so which NOAA data sets would be used to answer these questions? What steps are taken manually to answer these research questions? I'm sure everybody here is the hair on the back of their neck is starting to stand up with the complexity of that kind of question. So we conducted our research, we went through, and we had a couple of key takeaways and our findings from our research. Our key findings were people want us to enable users to identify available NOAA data sets through location-specific criteria. Through our research, we identified that a lot of people are just going to Google to search for these tools and what they're using. Or they already have a data set that they're so familiar with, they just look to that for everything. And when they need to procure a new data set or use it for new research, it's a pretty laborious task. So if we can simplify and enable them to identify data sets that are out there, because NOAA measures so much information constantly, previously, I should say, it's hard for them to locate what is and is not out there. So moving forward, they also wanted us to be able to facilitate the assessment and verification of data set components to support quality evaluation. One user actually outlined that around the year 2000, there are sensor and platform changes that they were aware of, and they decided to use that year to look for artifacts for those platform changes to validate whether the data set was of high enough quality for their purposes. So enabling them in some way to understand data density, data quality within this interface while also identifying what is out there. The next one, enabling fast visual representation of requested data sets. Users outline that I want to know what data is out there, and a way for me to validate it is to see it in a visual format, whatever that might be, whether it's time series representation, graph format, some representation that allows them to really understand what the data is without having to pore through it on their own. And then our next one, and our most kind of punchy one, allow the AI to communicate its confidence level in responses. Users outlined a pretty big hesitation around this hallucinations. The artificial intelligence spitting out an answer and claiming it as fact. They would prefer that whatever the tool is capable of doing is clear and communicating a level of confidence within that. And now, our most punchy one was that they're excited about the tool's potential, but cautious about AI in scientific research. The constant question of who's the tool serving, effectively outlining that we don't necessarily want this to conduct those scientific questions, we want this to enable what we're doing. So this threw a fairly big wrench in our initial proposed solution and how people would use this. So we essentially gut checked ourselves in, people want this to enable their science, which ultimately was our target, but we were trying to enable them in the wrong direction, in the wrong way. So how do we necessarily take all these key findings and translate them over into design decisions and direction? So again, data set exploration, data set quality, visualization, response confidence, and excitement and reservations. So insights to experience. The first thing is we want to make sure that we're accounting for the users in the loop. We want to be able to allow them to augment the input, change things, and really gut check the artificial intelligence so that it's not throw in a request, throw out an answer. Build for explainability. Allow this transparency, build trust through multiple methodologies, and allowing them to truly understand this. This kind of falls hand in hand with the clarity element. And then gain users' trust with transparency. Again, explainability, transparency, a little bit of splitting hairs there, but letting them see what data sets are leveraged, how we're actually processing this, and giving them all of the information up front that if they feel the need to digest this or check it, they can do so. And then the last one is don't automate everything. Automate what will only be beneficial. So we've gone through, we've conducted this research, and we're currently in the design and build phase. So this will be coming soon. Unfortunately, we're not in a position to share out our designs and our wireframes at the moment, but to kind of outline our next steps and phases, we're currently taking our findings and translating them into tangible interfaces, and then once we have those established, we're moving over into user testing, essentially gut checking ourselves once again. So this is actually where I'd like to propose a call to action for everybody. If you are interested in helping out with this project and you would like to participate in our future user interviews, if you find yourself interested in using this down the road, please feel free to scan this QR code. There is a form there that you can submit your information, and we'll reach out to you once we're conducting our user interviews. I see some people still. Perfect. So one thing, we've kind of covered a lot of area here, but if, let's say you leave this room and everything that we've gone over is jettisoned out of your brain, please remember just the last couple of slides here. A lot of people are approaching artificial intelligence with it being the tool. And there's a metaphor that I think is applicable in this setting. If you have a hammer, everything looks like a nail. You want to hit everything, it might not be the best way to solve it. I would propose that instead of looking at AI to solve everything and being the hammer, the tool, we look at it more as the material to shape the tool, the steel, the iron, whatever. And from that, we can start to shape the artificial intelligence to fit our needs a little bit more specifically. And by doing so, we start to meet the needs of our users a little bit more effectively instead of throwing out this huge tool or this huge suite of capabilities that might not get used ultimately. So, in conclusion, human-centered design isn't just a process, it's a pathway to impactful, trusted, and truly usable solutions for critical challenges like climate change. If there are 3 principles that I would recommend you approaching an artificial intelligence design challenge with, prioritize users in AI design, address cognitive load and build for explainability, and foster trust through transparency. So, we'll move forward into questions. Does anybody have any? I'll run the microphone so people on Zoom.
Thanks very much. Really, really interesting. Chris Lenhart, I'm at NCAR. How much are you encountering? It's partly like the new usage pattern teaching, but think back to when Google first came out. You had to learn how to use it to get the answers you wanted. And you'd be at a party, who could get the right answer fastest, And I think the same thing's happening with these kinds of AI interfaces, right? And I wonder how much your interactions with the NOAA folks reflected that, because everybody's used to using Google. They don't know how yet to leverage the AI interfaces. And you have to play around with it and learn it, like what it can do and that kind of thing. So did you encounter that kind of stuff?
Yes, very much so, actually. Within these interfaces, unless we provide some form of clarity of the limitations of, or provide context of what the LLM is capable of, people will go in and they'll just play around with it. They'll try and figure out the upper and lower boundaries on their own, which is completely natural. We want to play with tools and we want to explore. As far as enabling that within this setting where we're conducting really deep scientific data and providing it, that kind of creates a little bit of a challenge where if you don't provide the right answer the first time, you kind of lose that trust with some of these users, because we have people looking to this to enable the research that they're doing. And if we can't hit it out of the park on the initial ask, that puts us on the back foot effectively.
Harsha Hampapura from NCAR. Great talk. I have two questions. So, was the user persona supposed to be exhaustive? I hope not. Don't you want grad students, undergrads to use this tool? And secondly, why did you assume, define the user personas only with respect to their scientific interests, not in, you can also include their familiarity with AI, their software expertise. Somebody who would like to use an API to get the data that they want may absolutely hate an LLM giving their
of course.
data. Yeah.
So the initial personas that we outlined, we wanted to be a little bit broad. So we wanted to whittle down. If you imagine the potential of this tool in its impotence, we're looking at all the potential users. Are those scientists? Are those mechanics? Who do we actually want this to target? Because we can't necessarily boil the ocean. We need to do it one pot at a time. So the first pot that we wanted to address was the scientists, the people that would actually use the NOAA data. So to start off and make it more accessible and approachable from our solution, or how we would provide or approach the solution, is NOAA scientists. Who are those? Marine biologists, climate scientists. Let's kind of expand on those. And as far as assessing their LLM expertise, we did have a line of questioning within our user research where we were trying to figure out, are you comfortable with it? Are you not? So that we can actually kind of color our feedback at what we retrieved from those research findings. And most of the time when people were super experienced with the LLM, it was somewhat of a circular conversation where they already knew how to use it. They had confidence that they could tell it how to do anything that they wanted. So as far as building out feature sets, it didn't help us enable those that didn't know how to use LLMs. So there was a little bit of a double-edged sword. They're assets, but as far as enabling this to people that don't know how to use it and making sure that this was refined, the information was helpful, wasn't helpful in a sense. I hope that answers your question.
Thanks again. It's always nice to kind of have a UX tilt to the data discussions. I was curious if you could elaborate on sort of the queuing that allows you to provide additional context, particularly for an LLM style interface. Like when you're coming in, we all have these associations that come as baggage, and you broke down the design language we've developed around, for example, the hamburger menu. I'd love to hear a little bit more at length about what that evolving design language is for LLMs and how, in particular, you're trying to bracket people's expectations when they arrive at the interface.
Yeah, so I hate to say this, but it's a big it depends. It depends on who your target audience is. So for instance, scientific users, what we found was that citations, with that clarity of where we're getting the sources, that was a big key element. I want to know where this information is coming from. If any of you have used ChatGPT recently, or Gemini, both of them are doing this now, they're starting to create a source tab underneath whatever sentence that they provide. This is a developed pattern that we're starting to see expand across multiple LLMs that we want to leverage. We don't want to reinvent the wheel too much to where people have to refigure out how to use the tool, potentially running up against resistance to change. So what I would recommend is that if you ever come up with something if you ever have that question or find yourself asking a similar question when you're approaching these design problems, is figure out how users want to use it, essentially, because it's situational. When it comes to large digital products, Apple, Google, they do a really, really good job of designing out to the 80%. There's a theme where you want to solve for the 80 and be okay with not accounting for the 20%. And the reason for that is because you can't make it perfect. If you try and capture all of them, there's diminishing returns at a certain level. So define for yourself what that 80% is, and define for yourself what the 20% is that you're okay with going, that is such a hyper-specific need that we're not going to get value out of addressing that. And that's a constant battle with the evolution of this technology is, as things go on, the citations have started to become a need. So ChatGPT, Gemini, they started to integrate that into their interfaces. So we're in that infancy, not real infancy because it's been around a while, but infancy in a broader sense where people are starting to adopt it, where we've got to constantly iterate and adjust. So unfortunately, there's not a silver bullet at this point in time, but just be ready to pivot and watch how people use your solution. Yeah.
Is there any like design innovation that you've made that's independent from kind of the trickle down that's coming from OpenAI's platforms? Is there some design that you guys, for this specific product, isn't like the citations that's been a catchy
You'll just have to
button?
wait and see, is what I'll say.
When does it release?
Yeah, yeah. Would believe.
I actually have a follow-up to that, I suppose. Typically, when you think of these design patterns you're talking about, they come in, again, typically front-end or back-end, right? So back-end engineers are constantly chasing some new thing. When that was REST, that was a thing. Maybe it's GraphQL, whatever it will be, and it's how you're formatting your responses. And you see with interfaces like Bedrock, and you see MCP, where there's like no real agreed-upon design pattern from an API and a back-end perspective. You're also now developing new front-end patterns as well. How are you balancing your UX research on the front end and back end, knowing that you're going to have to tackle both almost simultaneously?
So being ready to pivot, that is kind of the theme that I would approach it with. For those of you that are familiar with Frank Lloyd Wright, there's a great quote within the design space. You can be the eraser on the drafting table or the sledgehammer on the construction site. And essentially what they're trying to communicate is that if you pivot too late, it's costly. It's laborious, it's a lot. So approaching this as trying to take it, to answer your question, looking at the holistic picture where what back-end decisions are actually going to influence the front end and taking those into account and really adjusting around those, because there's some back-end decisions that, thankfully, from a front-end perspective, they're behind a curtain to a degree. So I don't have to worry about them too much because they branch up into the response or the interaction to where the user doesn't really need to be aware of it. But in something like this, that transparency element really layers into some complexity with that backend. So one thing that we are exploring is a graph representation of our processes where we have a ton of nodes established and processes where we're dipping into a data set, analyzing it, and pushing it back. Well, this can be one process that branches out into 50 sub-processes. So how do we communicate that complex conduct that's happening behind the scenes to a user that isn't, hey, you have to know Python to digest this? The best way that I would approach it, there's a lot of avenues. We still need to develop it and test it against how people want to see it. So I don't want to prescribe a solution out of this answer. But one of the most effective that I've seen is a graph representation of those nodes where we're starting to show the relationships. Does that, I apologize, I rambled there a bit. Does that answer your question?
Yes.
Okay.
Was there, we have online, right? Is there anybody in Zoom chat with questions?
Sweet. If nobody else has, does anybody else have any questions before we wrap up? Awesome. Well, we're about half hour early. I would love to give you guys a half hour of your time back, seeing as it's 5 o'clock. So I hope you guys enjoyed the talk. If you have any questions, like I said before, please feel free to reach out to me in any format as well. That's odd. So yeah, you can learn more Element 84 at any of these locations. If you guys would like to just subscribe to our newsletter, we talk about a lot of these concepts from more of a back-end perspective and a front-end perspective. If you want to stay connected into all the methodologies that we're talking about. But thank you guys all for coming today. I really appreciate your time.